Good morning. Today we'll continue what we started last time, which is the review. Then we'll start with small parts from our first lecture. So let's first continue on what we reviewed last time. We talked about data communication in general and different layers that we'll consider in this course, including the physical layer and data link layer. And we stopped on the network layer. So, as I told you last time, physical layer and data link layer are responsible for hub to hub delivery. So it care about moving the data from one node to another node. But at the end, we need to send the data from sender to destination, and we will have multiple intermediate nodes in between, not just node to node. So who control the source to destination delivery of the data is the network layer. The main task of the network layer is to select the best path that the data should go or should take from the source to the destination. So network layer talk about our responsible for source to destination delivery of the packets. This including logical addressing. We have to include the IP address of the source and IP address of the destination, and routing, how to select the best route. And we'll consider in this course different routing techniques. Okay. So at each LAN, a router can receive the data from the host or from destination and decide which path we should take to the destination. And usually we select the path with the shortest path. Shortest path in terms of delay, in terms of cost. At the end, we need to choose the best path or shortest path. And at the end, we'll define one path to transmit the packet from the source to the destination. And at this layer, as I told you last time, we'll talk about packets. Data in this layer, we called it packets. In data link layer, it's a frame. So if we have this example, we need to move the data from node X to node Y. We'll have destination address and destination IP address and source IP address. So from the application, we receive the data. At the network layer, we add the source IP address and the destination IP address. And when we move the data from node to node, we add the source MAC address and the destination MAC address. This is the data link layer. So from node to node, if I move to router A, I will include the source and the destination MAC address of router A. But the IP address for the destination and source will be fixed because this is for the source and the destination. So whenever we move the packet through the path, always the IP address of the source and destination will be fixed. What would change is the MAC address of the source and the destination address. If we moved from router A to router B, we will change the source and destination address of router B. If we move to router C, we'll change source and destination MAC address. But in all cases, the destination and source IP address is fixed because the network layer is responsible for from the source to the destination, end-to-end delivery. Okay. And at the receiver, we'll make the inverse. We remove the data link header, we remove the IP header, we remove the TCP header, and we deliver the data at the end to the application. For the transport layer, transport layer is responsible for delivery of the message to a specific application. So physical layer moved the bits from node to node. The data link layer was responsible for framing and the MAC address between node and node. Network layer, higher layer, we talked about end-to-end delivery from source destination. Now, after receiving the data as a destination, transport layer move this packet to specific application because at the destination we may run different application. We may make browsing, video, audio. We may have different application. So transport layer responsible for deliver this packet to the specific destination. So now we add the TCP header, destination port and source port, which is the source application number and destination application number. So now we are higher layer and more specific to certain application. So from down to up, we start to move the data يعني step by step كده from certain application at the source to certain application at the receiver, but intermediate each layer will be responsible for a specific task, moving the data between nodes, moving the data on the end-to-end route, moving the data to specific application. Okay, but in this course we will not talk about transport layer. And I think you studied in network one two main protocols in transport layer, which is TCP and UDP. And the main difference in TCP support reliability, support error check, flow control. يعني it's more reliable for high quality applications. أما اليو دي بي unreliable, he just transmit the data, delivered or not delivered, delivered with error or not with error. It doesn't care about this. So UDP, unreliable delivery, no flow control, no error control. It just transmit the data. If it received correctly, it's fine. If not received correctly, it doesn't care about this. Okay. And then the main task is to deliver the data to the right application. So here in the TCP header, we add destination port and source port, and also some other parameters, but the main part is source port and destination port to deliver the data to a specific application. Okay. So now it's clear the difference between physical layer, data link layer, network layer, and transport layer. At the high level, we'll start بقى from today to study يعني each layer in details. But now at least you have the overview of the main tasks of each layer. Any question? I think you don't have new information in this review. Yeah. Okay. Okay. So starting from now, we'll start our first part, which is physical layer. And the first part of the physical layer is data and signals. I uploaded all this material on Blackboard. Did you receive this? Okay. And also uploaded the project description. And I said initially the phase one delivery at the end of this month, 30 of January. Just to prepare the groups and proposal what you will do in the project. Okay. So in the physical layer, the first part is data and signal, because as I told you, in the data link layer we prepare a frame after receiving the data from the application at TCP header, at network header, at data link header. Now we have a data need to transmit to the receiver. But to transmit this data through transmission media, physical layer deal with the bits. So at the end, this data should be encoding to bits. And the physical layer is responsible for moving these bits to the receiver. So the data in the data link layer is 0 and 1, and it's arranged in frames. Now to transmit this data, we need to transmit this data through electromagnetic signal. So to move 0 and bits and move it wireless or through wire, we put this data in the form of electromagnetic signal or waves. Okay, so we need to change the data into signals. So here in the first part, we'll talk about some characteristics of the data and some characteristics of the signals. That will help us on the physical layer بعد كده in talking about more specific tasks in the physical layer. So the first part, we need to deal with data converted to a signal, and this signal will be transmitted through the physical medium. So the main functionality of the physical layer is to create a signal. How we move this data. في الآخر, if we need to send an email, we have text. This text should be represented in a bit. This bit should be transmitted. So and I need to create a signal to represent the stream of bits to be transmitted through the wireless medium to the receiver. And for sure, physical layer decide on direction of data flow to which destination I will transmit this data, and decide on the number of logical channel, because we may have the same transmission medium but different user transmit at the same time. So in this case, we represent it by logical channel. And it's the same medium, but inside this medium, we can consider it as several logical channel, not physical channel, because physical channel at the end may be wire. It's a physical channel, one physical channel. But inside this wire, I can transmit multiple data. Each data can be represented by a stream. So I can transmit multiple streams inside number of logical channels. In this case, I name it logical channel because it's not physical, but in the same physical channel, I can transmit multiple logical channel to transmit the data from different sources to different destinations. Okay, so we'll review some. I think you touched some of these parts in signals and signal and system course. So data, when I receive the data from the application, can be analog or digital. Analog data is continuous information, represent continuous information, like our sound. Our sound continuous information. If we draw the sound, it will be something like this. So it's continuous. At any point of time, we have value. At any point of time, we have value. And if we define a specific period, we'll have here how many values we'll have in this period, for example, infinite. Because at each point we have value. So we have infinite values. So it's continuous space. We name this continuous space. So this type of signal is analog signal. Because it have a continuous space, have infinite number of values. Okay, in a specific duration. Digital data refer to information that are discrete. For example, text. يعني ده if I need to transmit sound over the channel, if I need to make a call, so I transmit sound, so it will be continuous like this. If I need to send an email, it will be text, and each word will be represented by a group of bits. So at the end, I will transmit group of bits like this. In this case, this is digital data because here it's 1, here is 0, minus 1, here is 1 or مثلا 0.5 and so on. So at each type, we have a specific value. We have discrete values. And for example, if I told you what the numbers of values in this period, it will be 1, 2, 3, 4, 5, 6, for example. So it has a discrete status or discrete values. So this is a digital data. طبعا example for the analog data can be sound, can be analog clock. Digital data can be digital clock, for example. So this is the difference between analog and digital data. We'll talk about that analog and digital signal and periodic and non-periodic signal. So data can be analog or digital, and this data received from the application. Okay. Analog data, continuous and discontinuous value. Digital data have discrete value and discrete values. السيجنال بقى the same. If I need to represent يعني الساوند would come مثلا from the application we have sound. This sound if I transform it into a signal, it will be something like this. So I transmit the data into a signal to be transmitted. For example, signal like sine wave. Okay. So I may represent مثلا for example ال1 by sine wave like this. And مثلا ال-1 I can represent it by inverse مثلا sine wave. So by this way, I transform the data into signal. And this signal has the same characteristic, can be continuous also or can be discrete. And can be analog and or can be digital. It's a signal also. The same again, analog signal have infinite number of values and continuous space. Okay? And this when we talk about analog signal or digital signal can be periodic or non-periodic. And we usually in communication we deal about periodic analog signal or non-periodic digital signal. let's take a comparison of analog and digital signal. This is two examples to analog signal and digital signal. Analog signal طبعا take continuous space, digital signal take specific values. Example for the analog data or analog signal can be human voice. Digital data can be data stored in the memory of the computer, which is zeros or ones. And this is the difference between data and signals, analog and digital. Now بقى one of the important characteristic is a periodic signal. Periodic and non-periodic signal. Periodic signal have a specific pattern that's repeated each period of time. So for example, if we have this sine wave, we have this pattern. And this pattern after this period will be repeated again. After this period will be repeated again. So each period, this period, T, each period, the same pattern will be repeated. Exactly the same pattern will be repeated. Signal. If, for example, here we have specific pattern repeated. No. So it's non-periodic. We don't have a specific pattern repeated. Each time we have different pattern. So the simple example for a periodic analog signal is sine wave. And non-periodic signal doesn't have a specific pattern repeated. So it can be in a shape like this. Doesn't have a specific pattern to be repeated. Okay? Okay. So now we talk about signal, periodic, non-periodic. البريودك بقى analog signal can be simple or composite. It's simple like this sine wave. This is simple. One sine wave, this is simple signal. If I combined multiple sine waves, يعني sine wave like this, sine wave like this, and sine wave مثلا with different frequency like this. If I added these three signals to each other, I may have, for example, I may have signal بقى like this. This signal periodic. But now this sine wave simple, but this is composite signal. This is multiple signal combined with each other to generate this signal. This is what we need and this composite signal is important. Anyone know why? Usually we don't prefer to send one signal like this. We prefer to send composite signal. Anyone can guess why? Cost of what? Cost of what? Exactly. But in this case, not we need cost. We need to send multiple data at the same time. At each time, only one signal. One this signal can represent مثلا 1 and this represents 0. يبقى each time you send here if you combine multiple bits into one signal, for example, I can transmit 101 at the same time. So I add more data to the same signal. So the composite signal is important in communication. Okay? يعني back بقى to the simple periodic analog signal, sine wave. Any signal بقى we defined it by amplitude, frequency, and phase to define a signal. So now we'll study بقى sine wave as an example because it's very important in communication system. It's used a lot in any communication system. Sine wave. We will define بقى amplitude, frequency, and phase with these different signals, and we will define the wavelengths. We'll see how we can represent the signal in the time domain and in the frequency domain, and we will see why we need to represent a signal in the frequency domain. We'll talk about the composite signal and how this composite signal will define the bandwidth. New concept in communication, important concept, what's the bandwidth of the channel. So step by step, we start by analog, simple analog signal like sine wave. Sine wave will have amplitude. So for example, these two signals starting at the same point, have the same phase, the same period, always have the same period, so it has the same frequency, but different amplitude. So amplitude is the peak of the signal reflect the energy inside signal. So if I put high energy to the signal, it means the amplitude is high. But if I put low energy, its amplitude is low. So the peak amplitude of the signal here defines the amplitude of the sine wave, and it represents or refers to the energy of the signal. Okay, that is the first الامplitude. البيريود طبعا هي الامount of time in second the signal need to complete one cycle. So this period is the amount one cycle is the period, the definition of the period. If I need to ask you what the period of the signal is, the amount of time in second a signal need to complete one cycle. This one cycle, or this is a pattern that will be repeated. The time of this pattern t, which is the period of this signal. For example, this signal can be slow signal, so it take a long time to complete one cycle, or fast signal, complete the period in very short time. So this is the period. Okay. الفريكونسي بقى هو what's the number of period in 1 second. يعني independent بقى ان البيريود وقتها قد ايه الفريكونسي at the end frequency عايز in 1 second. Here I fix بقى 1 second in 1 second. How many periods? For example, this is one period. يبقى الفريكونسي 1 hertz. البيريود in time طبعا. Here مثلا دي very fast فمثلا completed لو قلنا 1 2 3 4 مثلا فدي completed 4. The frequency will be 4 hertz. So the frequency, how many periods in 1 second? Completed in 1 second. Okay. So now we have the peak amplitude of the signal, the periods, and the frequency. طبعا from this definition, if I increase the number of periods, I increase the frequency. And to increase the number of periods, I need to decrease the time of the periods. To increase the number of the periods, to increase the frequency. So the frequency and the period is inverse proportional. If the period is very large, it means that it's a slow signal, it means the frequency is slow. But if the period is short, it means that it's fast signal or high, يعني have high variations, it means the frequency is high. So the first definitions is the frequency equal to 1 over t, inverse proportional to the period, where t is the time of the period. So the frequency inverse proportional to t. And vice versa, if I give you the frequency, the period will be 1 over the frequency. Okay. Now definition of the frequency is number of period inside 1 second. The first one in the first example, in 1 second we have 12 periods. So the frequency is 12. In second, and it's little bit slow signal, so we completed 6 periods in 1 second. It means that the frequency is 6 hertz. And inverse, the period is 1 over the frequency, so the period is 1 over 6 seconds. Okay. So if we need if we have the period, we can calculate the frequency. If we have the frequency, we can calculate the periods. اليونتس بقى. Units is very important. From now, any definition we'll talk, you have to define the units of this definition. Because if in any exam, in any question, you put the value without the units, it's useless. And also, you need to take care about what the unit I ask. In second, in millisecond. So you have to take care about how to change the units. So it's a common trick in any question or in any exam. take care about the units. Okay, so a period can I can give you the period in seconds, in milliseconds. It's 10 to the power minus 3 of seconds. It's microseconds, and same for the hertz can be in hertz, in kilohertz, 10 to the power 3, in megahertz, 10 to the power 6. So it's very important to know how to, if I give you in hertz and ask you about kilohertz, how to change, and so on. If I give you a time in milliseconds, you need to change it to second, then change it to hertz. You can't use مثلا in millisecond direct to hertz. You have to change it to second, then to hertz. So it's very important to know how يعني to convert any units to the other units. Okay. So let's take an example. The power used at home is at the frequency of 60 hertz. So the periods of these sine waves in milliseconds. If the frequency is 60 hertz, what's the time in milliseconds? يبقى التايم هو الانفرس of the frequency, so 1 over 60. But 1 over 60, it will give you the unit seconds. But the question asked about millisecond. So if you put it in second, it will be wrong answer. So we have to convert it to millisecond. Millisecond is small, smaller than the second, so you have to multiply by 10 to the power 3. Okay, so it's very important to care about the units. Another example, if the period is 100 millisecond, what will be the frequency in kilohertz؟ حد ممكن يحسبها بسرعة؟ مم. اوكي، بالظبط، ما ينفعش تقولي من الملي سكند للملي هرتز. فاحنا عندنا we have to change now. We have two steps to change the units. The time in milliseconds. So we don't we have to change it to seconds. Then calculate the frequency. But the frequency in this case will be in hertz. We need it in kilohertz. So we have to make another change. So take care. We have here two change for the units. So first we need to change the 100 millisecond to seconds. Then calculate the frequency from seconds to frequency in hertz. Then بقى convert الهرتز to kilohertz. يعني لازم الكلام ده كله كده يبقى في دماغكم، يتعمل في نص دقيقة عشان الكويز. يعني السؤال ده في الكويز المفروض يتحل في نص دقيقة. Okay. So 100 millisecond will multiply by 10 to the power minus 3 because I need second. So I multiply by 10 to the power minus 3. Then calculate the frequency 1 over 10 to the power minus 1. In this case, it will be in hertz. To convert it to kilohertz, I multiply by 10 to the power minus 3 again. Okay. So the frequency is the rate of change with respect to time. If the frequency is high, it means that the signal is changing very fast. If the frequency is low, it means that the signal change very slow. طيب, the change in a very short time means high frequency. For example, if our signal change يعني السيجنال كده كانت مثلا 1 0 1 بسرعه in very short time. The frequency is high. So always the changing in time. If the change is very fast, it means على طول high frequency. If the change in a long period of time يعني from 1 to 0 to 1 in مثلا 1 second, it will be it means that we have low frequency. يبقى لو the change كان over long span of time or long period of time, it means low frequency. Like we talk, if we talk very fast, I change my words very fast, and time mean I talk with high frequency, and so on if I talk slowly. So if a signal doesn't change at all, it means frequency zero, and it doesn't change. For example, this signal, what's the frequency of this signal? If I give you this signal in time, what will be the frequency? Zero. طيب العكس بقى if I give you signal it change instantaneously يعني كده what will be the frequency؟ يعني هنا from this point to this point it change in almost no time. So what's the frequency? Infinite. With it's change in almost no time. So it means the frequency is almost infinite. Okay. So this example for signal in time. Here we have low frequency, and here we have change very fast in time. So we have change in the frequency but in high value. So this is a signal in time and this signal in frequency. I need to represent signal in time and frequency. The third definition بقى الفيز. احنا اتكلمنا على الامبليتيود، اتكلمنا عن الفريكونسي اللي هو related to the period. Third definition is the phase. الفيز هو الستارت بوينت بتاع of the signal. If the start point at zero, it means that the phase is zero. If the start point at مثلا shift in the phase. Instead, we start at phase 0, we start at phase 90. And this phase can be in degree or radian. So the phase is the position of the wave relative to time 0. When I start at time 0, what was the signal? It was started at 0, or started at 90, or started here at 100 before shifted phase. Instead of starting at 0, in B we shift the phase by 90 degree, in C we shift the phase but by 180 degree. So a sine phase with phase shift 189 or half cycle. Okay, because one cycle is 360 degree. This one's complete one cycle. So if I shift the signal with respect to time 0, I can calculate it the phase in degree or in radian. Okay. So for example, here an example, sine wave with offset 1 over 6 cycle with respect to time 0. So what will be the phase in degree and radian? And that complete cycle 360. I shifted 1 over 6. So one complete cycle is okay, exactly. يبقى 360 divided by 6, it's 60 degree. This 60 degree I need to modify it to radian, so multiply by 2 pi over 360. I can convert it to radian. Okay, so this is the definition of the phase. And also take care about the units. If I need it radian, per degree, or in cycle. بعد كده بقى definition of the wavelength. The wavelength is a distance a signal can travel in one period. For example, here, so signal travel the wavelength, the distance that a signal takes to move one cycle. Well, if I consider this x-axis is transmission median, so at time t signal was in x plus this is one cycle, but we have in the median بقى or one what the distance we travel. This is definition of the wavelengths. طب من الديفينيشن كده الويفلنس will depend on what؟ الويفلنس هو الديستانس، فهيديبند على ايه بقى؟ انا عايز اموف one period في التايم، يبقى هيديبند على ايه؟ على الفريكونسي، لان البيريود قد ايه؟ لان لو البيريود كانت كبيره يبقى I need to take long distance to complete this period. يبقى اول حاجه على البيريود، على البيريود او على الفريكونسي. تاني حاجه، لا، ما هو التايم هو البيريود. على السبيد، بالظبط على السبيد وذ سيجنال. هل السيجنال ترافل with high speed or low speed؟ عشان هتقطع في الاخر distance، زي السياره. you move a distance so you need to it's function of your speed and your cycle اللي انت to complete it. So the wavelength equal to propagation speed, my speed اللي السيجنال travel with, multiply by the period or 1 over the frequency طبعا لان البيريود because I need to travel with this speed. So the distance هتبقى السبيد في البيريود، لان دايما السبيد هي عباره عن distance time. فالسبيد في تايم هو الديستنس. ده اي حاجه حتى يعني even for cars يعني السبيد دايما هي الديستانس اللي انت قطعتها قد ايه في تايم. الويف لينث هو distance so it's the propagation speed multiplied by the period or طبعا 1 over the frequency. طيب after بقى we define بقى ال sine wave and different parameter amplitude phase frequency. Now I need to represent بقى السيجنال in time and in the frequency domain. فالسيجنال مثلا signal like this دي simple sine wave amplitude 5 volt, frequency 6 period in 1 second, فالفريكونسي 6 هرتز. فthis is in time. If I need to represent in frequency يعني instead of x axis time I put frequency، هيبقى الشيب عامل ازاي؟ ايه؟ انت عندك الفريكونسي كام؟ يعني one value، فهل بيتشنج؟ fixed. So all the signal in time هتrepresent with one value in frequency. فبقى why بقى we need بقى frequency domain in this case؟ why يعني why in communication we talk about frequency domain؟ ليه we don't يعني plot the signal in time and that's it؟ ليه we care about the frequency domain؟ عشان الاكزامبل ده. why we need example زي ده. if I have three signal like this وده التيبيكال اللي بيحصل في الكوميونيكيشن، ان انا مش هبعت وان سيجنال. التيبيكال في الكوميونيكيشن انا ببعت ممكن hundreds of signals. ففي التايم هتبقى very complicated. في الفريكونسي بقى لو if I need to plot this in frequency exactly. لا هو تحت اهو 8 and 16. all this complicated figure will represented by three values of frequency. We have 16 frequency with amplitude 5. So this is the beauty or the importance of the frequency domain. We move complicated signal. This form بقى هتبقى important كمان في الديفينيشن بتاع الباندويث. Okay. So can I stop here? Any questions?